Hi guys, welcome to today's video, Grade 12 Differential Calculus 2019 exam paper. Without further ado, let's get to it. Question 7.1. Given f of x is equals to x squared plus 2, determine f prime of x from first principle. That is, we are asked to differentiate the function using first principle. And we know that we're going to use the following formula, which goes f prime of x is equals to limit as height approaches 0, f of x plus h minus f of x all divided by h. Now, in my formula rather, wherever I see f of x plus h, I go to my function. Where there's x, I substitute in x plus h. And then for f of x, where I see fx, I leave it as it is because that is f of x. Doing that, I will have x squared as x plus h squared plus 2 minus f of x, which is x squared plus 2 all divided by h. Expanding the x plus h, I will have the following equation, and then expanding it further, I will have x squared plus 2xh plus h squared plus 2 minus x squared minus 2 all divided by h. And now grouping the like terms, I'll have x squared minus x squared plus 2xh plus h squared plus 2 minus 2. The x squared and the x squared will minus each other out, leaving it to be 0. And the 2 minus 2 will cancel each other out, leaving it us with 0. And hence we will be left with limit as height approaches 0 of 2xh plus h squared all divided by h. On the numerator, I can see that there's a common factor of h. I can factor that out. And for 2xh, I'll be left with 2x, and for h squared, I'll be left with h. And the h on the numerator and the h on the denominator will cancel each other out, leaving me with limit as height approaches 0 of 2x plus h. And now substituting in my h as 0, I'll have 2x plus 0, and hence my f prime of x will be 2x. Let's move on to 7.2. Determine dy dx if 7.2.1 y is equals to 4x cubed plus 2 over x. Here we are not told to use first principles. We can use any derivative method that we know or are comfortable with. I'm going to use the familiar one using differentiation rules. But first, I'm going to write my equation in the form that it will be easy for me to differentiate it. Doing that, I will write it in the form of y is equals to 4x cubed plus 2x to the power negative 1. We know that x on the denominator, it can go into the numerator, but when it climbs up, it changes the exponent of the power, and hence the power of 1 becomes negative 1 now. And now that function is nice and easy. I can differentiate it quite simply, and doing that, I will have y prime rather is equals to 12x squared minus 2x into negative 2, and bringing back my function into the form that I found it in, I'll have y prime is equals to 12x squared minus 2 divided by x to the power negative 2. Moving on to 7.2.2. Again, that function is not in a friendly form. First, I'm gonna simplify it so that I can differentiate it nicely. Doing that, I will have to get rid of the square root and the powers that are multiplying each other out. So first I'm going to say 4x to the power 1 over 3, because that cube root becomes the power of 1 over 3, as you can see. So I'll have 4x to the power 1 over 3 plus 9. And again, the squared there, it will translate into the 3 and into the x cube, leaving the 3 to be 9 and the x cube to be x to the power of 6. And now my function is nice and easy. I can differentiate it quite simply, and differentiating it leaves me with y prime is equals to 4 over 3x to the power negative 2 over 3 plus 54x to the power 5. And I am done with that question. Going to 7.3. It says if g is a linear function with g of 1 is equals to 5 and g prime of 3 is equals to 2, determine the equation of g in the form y is equals to ... That problem statement, g of 1 is equals to 5, that is a coordinate. That means in my function, where the x value is 1, the y value is 5, and hence I've written down that coordinate of 1 is to 5, as you can see on my screen. And we know that If we substitute in an x value into the derivative of a function, we get the gradient of the function at that point, and hence the gradient at g prime of x of 3 will be m is equals to 2, as again you can see on my screen. And now I have a coordinate and I have a gradient, and I can use those two to find the equation of the straight line or of the linear function. I first write down the formula 1 is equals to mx plus c, that is the general formula of a straight line, and substituting in the m, the x, and the y, I get 5 is equals to 2 multiplied by 1 plus c, and then solving for c, I get 5 is equals to 2 plus c, and hence c will equal 3. And now substituting in everything back into my straight line function, I will get y is equals to 2x plus 3. Now moving on to question 8. The problem statement reads as follows. A cubic function h of x is equals to negative 2x cubed plus bx squared plus cx plus d cuts the x-axis at negative 3 is to 0, negative 3 over 2 is to 0, and 1 is to 0. 8.1. Show that h of x is equals to negative 2x cubed minus 7x squared plus 9. First thing I'm going to do, I'm going to write the general formula of my function in a different form. We know that we can express the general formula of a cubic function in two forms. One is the form shown by the question, and the second form is this: a into x minus r1, x minus r2, and x minus r3. And those r1, r2, and r3, we are given them because we know where the graph cuts the x-axis. Now, the first value, substituting in everything, I know that a is equals to negative 2, and I've substituted that in. R1, it will be 3 over 2, R2 will be 3, and R3 will be 1. Notice that when I substitute in my values into the formula, they change signs. Negative 3 over 2 became positive 3 over 2, negative 3 became positive 3, and positive 1 became negative 1. You have to be sure to do that when you treat a question like this. Expanding that question a little bit further, or putting it in a position where it will be easy for me to expand, I've multiplied the 2 into the x plus 3 over 2 so that I have 2x plus 3. I don't have any fractions. Now I can expand my function nicely. Now, starting the process of expanding, I first expanded the last two brackets. You can start with any two brackets. There doesn't have to be a form. You will arrive at the very same answer. Expanding x plus 3 multiplied by x minus 1, I get x squared plus 2x minus 3, and the 2x plus 3 is still there. And finally, expanding those two, I will have negative of open bracket 2x cubed plus 4x squared minus 6x plus 3x squared plus 6x minus 9. Simplifying my function a little bit, I will get negative 2x cubed plus 7x squared minus 9, and hence the negative multiplying everything will leave me with negative 2x cubed minus 7x squared plus 9, and that's what the question has asked me to show, and I've shown it. Now moving on to question 8.2, which states, calculate the x coordinates of the turning point of h. First thing I am gonna do is to differentiate my function, and doing that I will have h prime of x is equal to negative 6x squared minus 14x, and then equate that derivative with 0, and hence I will have negative 2x multiplied by 2x plus 3 is equals to 0. What I did there is I factorized my derivative. That's all I did, and hence I will have an x value of 0 because negative 2x is equals to 0 will leave me with an x value of 0, and another x value of negative 7 over 3 because 3x plus 3 is equals to 0 will leave me with an x value of negative 7 over 3. Moving on to 8.3. Determine the values of x for which h will be decreasing. First, I need to draw a sketch. It doesn't have to be very accurate, because I know that my a is negative, and hence my graph will start at the top left corner going to the bottom right corner, as you can see on my sketch that I've shown you there. And I know that the far left coordinate is negative 3 is to 0, and the middle coordinate is -3/2:0, and the far right coordinate is 1:0, as you can see. Where the graph is decreasing is where from left to right the gradient of the graph is negative, or the graph is going down, and we can see that from -3 up to -infinity. That means starting from -3 going to further left, the graph is decreasing, because at those coordinates or at those points the gradient of any tangent to the graph will be negative, and hence from -3 up to -infinity the graph will be decreasing. Or in mathematics, I know that that is for all x values that are less than -3, as you can see. And now, that is not the only case where the graph is negative or the graph is decreasing. Looking at my graph, starting from 0 up until far right, I can see that the graph is decreasing again. From left to right, it's going down, and hence from 0 up to positive infinity, the graph is decreasing, and hence for x is greater than 0, the graph is also decreasing, and hence I have two cases where the graph will be decreasing. That is, x is less than -7/3 and x is greater than 0. Moving on to the last question or sub-question of question 8. For which values of x will there be a tangent to a curve of h that is parallel to the line y minus 4x is equals to 7? For a question like this, you should be careful to first draw the straight line in its form. If we write that straight line in its form, the -4x, hence the gradient will now be positive, and the gradient for that function is +4, not -4. So be careful to first write the equation of the straight line in its form. First step, I write down the equation of my original function h of x, which is equals to -2x cubed minus 7x squared plus 9. And deriving that equation, I get h prime of x is equals to -6x squared minus 14x, and then equating that to 0, I get -x squared minus 14x is equals to 0, and hence 4 is equals to -6x squared minus 14x, because I was told that the gradient of the graph, or I know that the gradient of the graph at that point is 4, and simplifying that, I get 6x squared plus 14x plus 4 is equals to 0, and that's a trinomial, and we can write it in this form. Dividing by the highest common factor, which is 2, I get 3x squared plus 7x plus 2, and hence I can factorize that one, leaving me with 3x plus 1 multiplied by x plus 2 all equals 0. If you don't know how to factorize, you can always use the quadratic formula, and that will leave me with x values of -1/3 and -2. And that is the end of question 8. Let's move on to question 9. The problem statement reads as follows. A cone with radius r centimeter and height of AB is inscribed in a sphere with center O and a radius of 8 centimeters. OB is equals to x. Volume of sphere is equals to 4/3 pi r cubed, and volume of cone is equals to 1/3 pi r squared multiplied by h. 9.1, it says, calculate the volume of the sphere. First, I was given the equation for volume of the sphere as 4/3 pi r cubed, and hence I can see that my radius from inspection, I can see that the radius OA is a radius and it's equals to 8, and hence all radii are equals to 8. Substituting in that 8, I get 4/3 pi of 8 cubed, and that will give me a volume of 2048 pi, all divided by 3. And I like to leave my answer in that form and not to round it off at this point, because this is not the end of the question, and hence I wouldn't encourage you to round off at this early stage, because you're still gonna use that value, and hence when you round it off, the results are gonna be less and less accurate. Now let's go to 9.2. 9.2, it says, show that r squared is equals to 64 minus x squared. I know that through Pythagoras theorem, it states x squared is equals to h squared plus y squared. Looking at now my diagram, the hypotenuse is a radius, and I know that radius is equals to 8, and hence h squared will become 8 squared. looking at the x, or the horizontal part of that triangle, I see that the horizontal part is r, and hence x squared will become r squared. And looking at the y squared, which is the vertical of that triangle, is ob, and ob is equals to x, and hence y squared will become x squared. Doing everything, or substituting in everything I just said, I get 8 squared is equals to r squared plus x squared. Simplifying that further, I get 64 is equals to r squared plus x squared, making r squared the subject of the formula. I get r squared is equals to 64 minus x squared, and I've shown what the question has asked me to show. 9.3, it says, determine the ratio between the largest volume of this cone and the volume of the sphere. Now, when it says largest volume of this cone, I know that one way or the other, I have to find a way to derive an equation, because that's the only way I can get to a maximum or to a minimum. Let's first deal with the volume of the cone, because the volume of the sphere I've already calculated for it and I know it. So let's not worry about that now. Let's first worry about the volume of the cone. First, I know that the volume of cone is given by the equation 1 over 3 pi r squared h I was given by the problem statement. And now, my variables, I need to represent them in terms of x, and hence 1 over 3 is a constant. I don't need to worry about that. Pi is also a constant. I don't need to worry about that. R squared, however, is not a constant, it's a variable, and hence I need to convert that into x, and h is also a variable. I need to convert that to x. But I know that recently I've shown that r squared is equal to 64 minus x squared, and hence for r squared I'm sorted. Now let's look at h, the height of the sphere. We know that the height of the sphere is AB, and looking at AB is equal to OB plus 8, which is equal to x plus 8, and hence for h I'll substitute in x plus 8, and substituting in everything I've just said, I get 1 over 3 pi of 64 minus x squared multiplied by 8 minus x. And now expanding my brackets, I get 512 plus 64x minus 8x squared minus x cubed. And now multiplying the 1 over 3 pi, I get 512 pi over 3 plus 64 pi over 3x minus 8 pi over 3x squared minus pi x cubed, all divided by 3. And now I can finally derive or find the derivative of my function, because it's now in all terms of x. The derivative will be 64 pi over 3 minus 16 pi over 3x minus pi x squared. And hence I need to now equate it to 0, and hence I'll have 0 is equal to 64 pi over 3 minus 16 pi over 3x minus pi x squared. Now multiplying everything by 3 to eliminate the fractions, I will have 64 minus 16x minus 3x squared is equals to 0, and I've also divided out the pi. 0 divided by pi will still be 0. 64 pi divided by pi will be 64, and so on. And now I have a nice trinomial. Factorizing, I get 8 minus 3x into x plus 8 is equal to 0. Again, if you're not sure how to factorize, don't lose marks unnecessarily. Just use the quadratic formula. You will arrive at the same answer. And that will leave me with x values of 8. X is equal to 8 over 3, or x is equal to negative 8. And now I know that I'm calculating for volume, and a volume can't be negative, and hence the negative 8 value, I'm going to ignore that. That cannot be my volume, and I'm going to take the 8 over 3 value. Moving on, I know that my x is equal to 8 over 3. Now I'm going to go back to the equation that I found in 9.2, which is r squared is equal to 64 minus 8 over 3 squared, and find what? And find the value of r squared, not in terms of x, because I've already found x. I'm just going to find the literal value of x squared, of r squared rather, and hence wherever I see 8 squared, I substitute in 8 over 3 squared, and doing that I will have 64 minus 8 over 3 squared will give me a r squared value of 512 divided by 9. And I do the same for h. H is given by x plus 8, and hence it will be 8 over 3 plus 8, giving me an h value of 32 over 3. And now I'm gonna try and find my volume or volume ratio. V cone over V sphere, it will be 1 over 3 pi r squared h. That is the volume of the sphere, all divided by 2048 pi over 3, and that is the volume that I calculated for the sphere. Substituting in the values for the volume of cone, I will get 1 over 3 pi multiplied by 512 over 9, which is my r squared, also multiplied by 32 over 3, which is my height, all divided by 2048 pi, all divided by 3, which is the volume of the sphere. And now that will dissolve to give me a value of 8 over 27. And now I can finally round it off to give me a value of 0.3. And that concludes 9.3 and hence concludes this lesson. Thank you for watching. To support the channel and help more students access free lessons, please like the video and subscribe if you're new to the channel. For additional learning materials and updates, visit our website using the link in the description below. Keep studying hard and I'll see you in the next one. Cheers.